this video, I'm going to talk about the partisan model by Elisina. So the situation here is that the objective function of a political party is to maximize its utility in period 1 and period 2, and we assume that the party is either the left-wing or the right-wing party, and in each period the utility function is going to be like this, and it's going to be party specific. In particular, the left-wing party is going to demand the output gap to be bigger than the right-wing party. And also note that this term here is linear rather than quadratic. And as usual, we have the Phillips curve. However, now we have no uncertainty in the Phillips curve, and if there's rational expectation, there's going to be perfect foresight, and this condition will be used later. So we can look at the timeline of the events happening. In period 1, people form the expectation for inflation, period 0, and then at the end they take this expectation to the end of this period, and then we have an election in period 1, and then we proceed into period 2. Okay, so period 1, inflation output will be realized after this expectation is formed, but in period 2, the election outcome will be known by all the people. Okay, so solve this needs backward induction, so we begin with the second period. First we substitute PC into here, and then substitute this in U1 and U2, and also beta here is the discount rate, of course. So after we substitute in, we do the first order condition with respect to Y2. The incumbent party chooses the Y2 that maximizes its intertemporal utility VP. So we got the first order condition, and we substitute the Phillips curve back in order to simplify it, and we get the inflation. Note that the inflation is subject to inflation bias, and that's because they demand a higher output gap here. And the superscript P here means that this equation is dependent on the election outcome. So for both left and right wing party, this equation is to be of this format. But notice that the inflation bias will be higher for the left wing party, because here will be lambda L, which is bigger than lambda R. And we need to find the expectation of inflation in order to find the outcome of YT. So we take expectation of pi to p here and get this expression, and then there's no certainty in the Phillips curve, and hence we get the perfect foresight outcome. Okay, so this is because the election is taking place in period 1, and in period 2 everyone knows the lambda, so yeah, they just take expectation of pi 2 because they know what will happen if each party gets elected. They will choose a specific lambda 2. okay, we substitute this and this into PC, so we get that y2 is equal to y bar, and this is the natural rate hypothesis. Okay, we now turn to period 1, so we do the first order condition and substitute PC back, and then we get the inflation bias again. Now we can also see that this is wrong here, but this one is the inflation expectation people have in the first period, and since they are uncertain about the election outcome, they take the expectation of the two possibilities of inflation, and the probability distribution is given by this, and where P is the probability of re-election of the left-wing party, and 1 minus P is that of the right-wing party. Now we continue to substitute what we have for the inflation outcome in period 1, and then we simplify to this equation, substitute it back to the Phillips curve as well as the inflation outcome for the party, and then we get the outcome of output. Notice that in this period we no longer have the natural hypothesis. In particular, we are going to get a temporary boom if the left-wing party is elected, but notice that in the second period we get back to normal, and we are going to get a temporary recession if the right-wing party gets elected, and also this is temporary only. So to summarize, in this model we get both inflation bias and political cycle, and hence this model is called the political business cycle model.